Hello students, I am Professor Ambika Devi, Assistant Professor of Physics, Government First Grade College, Bidar. Today's video is related to session 38 of BSc 5th Sem, that is Solid State Physics course, and which is prescribed in the colleges affiliated to Karnataka State Gulbarga University, Kalburgi. So let us now begin with the session which is related to electric susceptibility. First we will discuss about electrical susceptibility. Okay. What is electrical susceptibility? How it is defined? When an electric field is applied to a non-polar structure, non-polar substances, its molecules are polarized and aligned along the direction of the applied field. Means when external electric field is applied to a some non-polar substances, then what happens? Molecules are get polarized and aligned along the direction of the applied field. Okay. Then the magnitude of the polarization depends upon the magnitude of the applied electric field. Magnitude of the polarization P is directly proportional to the applied electric field E. P is proportional to E. Here some proportionality constant is there, that is psi. Psi is a constant, and this proportionality constant is named as electrical susceptibility of the dielectric, and it has no unit. Okay. The electrical susceptibility psi is dimensionless. It has no unit. It is the dimensionless constant that indicates that degree of polarization of the dielectric material in response to an applied electric field. The greater the electrical susceptibility, the greater the electrical susceptibility, the greater is the ability of the material to polarize in response of the field. Okay, and reduces the electric field inside the material. So electrical susceptibility is defined as the constant of proportionality relating a electric field E to the induced dielectric polarization density. Here electrical susceptibility is defined as constant of proportionality relating an electric field E to the induced dielectric polarization density. P is equal to epsilon psi E. Here P is the magnitude of polarizability, E be the applied electric field, and all of us we know that epsilon naught is the electric permittivity of the free space, it is constant, and psi is also a proportionality constant, and it is also named as electrical susceptibility. So electrical susceptibility is defined as the constant. Electrical susceptibility is a constant which is proportionally relating the electric field which is induced in the dielectric polarization density. This is about the, and one more thing students, susceptibility is also defined in terms of P polarization, magnitude of the polarizability, epsilon E, epsilon permittivity and applied electric field. That equation is psi is equal to P by epsilon E. So psi is also expressed in terms of magnitude of polarizability, permittivity in free space and applied electric field. So finally it is concluded that electrical susceptibility is defined as the constant, it is a constant, and it is also relating to a electric field to the induced dielectric polarization density. This is about the electrical susceptibility, and now we will discuss about polarizability, and it is represented by alpha. Here when an electric field is applied across the electric material. When electric field is applied to the dielectric material, what happens? It become polarized. It become polarized and acquires a dipole moment. Means positive and negative charges are get separated by some distance and dipole moment is produced. If P be the dipole moment acquired due to the local electric field EL, then that magnitude of polarizability is directly proportional to local electric field EL, and P is equal to some proportionality constant EL. Here this proportionality constant is named as polarizability. Okay. So here the electric dipole moment of an atom is found to be related to the electric field. From that definition, then alpha is equal to, alpha is the proportionality constant and it is named as polarizability. Then this polarizability alpha is defined as the ratio of induced dipole moment to the electric field, that is alpha is equal to mu by E. And there are three types of polarizabilities are there: electronic polarization, ionic polarization and orientation polarization. Okay, thank you.